No, it's fine actually. Otherwise, I will be like Arya and feel sleepy. Okay, I'm not paying attention to you, Arya. So tell me, do you have any idea about the 100 kilowatts? So assuming that you have a generator which provides 100 kilowatt power. So how much it is? You can make the light, or how many buildings you can provide electricity for it? Yeah, assuming that you have a this apartment building, it has 200 um, block, I mean flat. So how many of them can be supplied by 100 kilowatt? All of them. You share between them. Okay. So what about you? What is your name? Rasturi? Kasturi? Kasturi. What about you? How many of this flat can be supplied by 100 kilowatt? No, no idea. How many? 100? 500? So 500 between, no, 1000. No, I'm not talking about the, I'm saying that, you have a one block, okay? So you have a dishwasher, clothes washer, television, light, but you cannot say that because we have a counter, okay? Then we have also this fuse, okay? Yes, 15 ampere. Yes. So if we consider, yes, but single phase, if we go three phase, it could be something like 6 kilowatt. Normally for such a cases, actually, each building, I mean, you're not guilty if you don't say, okay, so 6 kilowatt for one. No. I'm just going to give some idea about that, if later someone asks that, what is the rate of the power for each residential building, normally 6 kilowatt can be enough. Okay, 6 kilowatt. Yes. So it can be roughly 17 building can be supplied by 100. 100, I mean 102 is exact. If they use the nominal power. So anyway, if you see in this technology, it means that Edison models could be somehow useful for some small community. So it could not actually supply the one shopping center or this type of things. And the other problem was that, not problem, I don't know if it's problem or not, but it was DC. Is it good or bad? Here said that, okay, loads were incandescent lamp and possibly DC motor. So it means that there is no opportunity for AC model because that time we didn't have DC AC converter, even we didn't have DC technology. By the way, do you know that this Millennium Prize awarded to Indian professor in Finland because he was the person developed IGBT? Probably, yeah, this end of 2024. I forget the name, but he was from the North Carolina and he came to also Finland. Anyway, so we didn't have converter to convert AC to DC. So it seems that only you could supply the DC load. So it was not somehow good. And the other was that it was a small power plant, so, and the other problem was no voltage transformer. You had 110, so if you want, if not, we have no possibility for you. And the other thing is that it was no transmission line for that one. It means that you should build this generator close to the load center. So no opportunity to go out of the city and provide the electricity and distribute between by transmission line and then distribution. And so this is another problem. And okay, that's enough. We have too much problem, seems. Yeah. So okay, but the other side, we had the Nikola Tesla close to the Niagara Fall. And he used actually this hydro technology and provide the AC power. So it was a large power plant. It had actually 38 generator, which provide the 65 kilovolt ampere, 65,000 kilovolt ampere, and the voltage was quite high. So it means that the current goes down and you could transfer for the longer duration, and it was also three-phase, so you could use for AC motor and this type of devices that need high power also. So interesting topic. So if now I ask Abby, which one do you prefer? What do you see? Which one is better? Which model, Nikola Tesla's model is better or Edison's model? Tesla's model, exactly. Yeah. So we have a plenty of good reason that Edison model doesn't have. So then seems that Edison is guilty and is failed. So just close this part and said that we have Nikola Tesla. Then by this we see that from 1880 up to 2000, power can only be supplied nearby loads for the Edison model. So if we get back to Edison model. And then we need a small generation close to the load center, which needs the space, provide some noise and lots of other things. So, and it was also suitable for the DC, assuming that we have such a problem here. Then nowadays we have the DC actually AC converter, but that time it was not suitable. Also could not be transferred to other voltage. It is not flexible, and we need to actually provide the lots of generation. So it was somehow costly, and it was not efficient because we use the coal-fired power. Actually, this type of coal-fired power plant was not that much efficient. So, but hydroelectric was good, and no suitable for induction motor. It was DC. So seems that it was not good generation. So now we get back to the traditional technology for the grid. So we have actually generation, transmission, and distribution. Am I right? So we generate the electricity, increase the voltage level, and transfer to long distance. So why do we need increase the voltage level? So when we increase the voltage, current goes down. So, yeah. Sorry? Okay. Yeah, this is also, yeah, it's also written. Sorry? Losses, yeah. I mean, we have a lots of reason for that one, but the main reason is the losses. So, then it is also centralized and passive architecture. So what does it mean by passive? Does anybody knows what is things? Observe the energy. Yeah, it's coming from the electric circuit. Okay, this is true also. But here means that you cannot connect something like a renewable energy to this type of actually. This is why we said that you can generate electricity, but you cannot connect because grid code doesn't let you. So this is the meaning of passive. But what you mentioned is also correct for the element. Okay, so it was extensive and very complex system because we have a plenty of relay to monitor the system. Fault happening, you don't know where it's happening. You use the distance and see that, distance relay to see that, what is happening. Okay, so it is not that much easy to control it. And it has a complicated control. It means that you have one option that, generation must be more than consumption, otherwise you have outage. And not reliable enough for some application. So assuming that you have a steel company, then you have a molten actually steel goes in the direction to make something, then outage happening. You don't have outage in Finland, in India. You probably have, no? You have outage in, okay, so it means that it's not reliable and then you cannot do anything. Several actually, yeah. So this type of problem happening also. So it's not reliable for sensitive loads. And relatively inefficient. Why is not efficient? Because we have transmission line, we have distribution line, and always generation is far from the consumption. We have losses. Yes. Okay, this is one reason. And stability issue also one problem. Does anybody knows that you young, actually, gentlemen and ladies, do you know what is the meaning of the stability? What is the stability? Mm-hmm. Okay. Let's ask you. What is your name? Pachi. Prachi. Sorry, Prachi. So, do you know what is the meaning of stability? Exactly, yeah. So, a system is stable if the relay that we have or protection device is a very easy way to say that it doesn't react. So, distribution? Yes, yeah, but I'm saying that, the stability is return back the frequency and voltage. So if something happens, for example, a fault happening, then we have the fault current is very high, voltage goes down, and the under actually nominal level, actually this voltage relay react and disconnect it. So these type of things make the system unstable. But when the system generation is less than consumption, it means that we cannot supply the loads and system will be unstable and outage happening. So unsecure. Why are conventional grid are not secure? Does anybody knows? Except that PhD student close to the graduation. Why are PhD? Why our system are not secure? Because if, for example, you have a generation, transmission, distribution, long distance, and a storm happening, a tree fall down over the transmission line, and outage happening. Okay. Mm. Mm. Yes. Yeah. This is one, and another thing is that the nature of this event is reducing the security of the system, because you have the physical transmission line, and then storm can provide the unsecurity for that one and fault happening. So seems that this is also one problem, and always we need to balance generation and demand, otherwise we have outage, and lack of flexibility means that the system is not that much friend with the other components. So we define something and we don't need to, we cannot easily to change any component, otherwise some other issue will happen. So now we get back to the history. Do you like the Edison model or not? Edison model is close to the load center. So it means that consumption is close to generation, and you don't have any transmission and distribution line. So it means that your system has less losses and also is more secure, because when you don't have this type of transmission or distribution line, the event will not impact on it. And also it is more reliable, more efficient, more secure, more resilience, more anything you want to say. Okay? So do you believe that now Edison model is good? Who didn't like it? Abby, you? You didn't like it, yeah? You must buy chocolate for your answer. Okay, anyway. So it is more efficient because we don't have losses. So let's see the next one. As many small power station needed. This is the concept of distribution. It means that if we have the Edison model, in fact, we don't need to build a new transmission line. So we can use the same one, but a small power generation can be also based on the Edison model and supply the load, because we build it close to the load center. Existing grid present issue with the DC loads because they are AC, or to operate induction motors at different speed. So Edison system suitable for such loads. And also we can say that because the nature of the Edison model is DC, so we can directly